Yes, Stas. Good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Okay, Aryan, no issues. So, who are there? Astha, Ahmed, Alan, Anushka, Aryan, Imad, Jiva, Razan, Zaid. Imad, you were not attending the classes?
Yes, ma'am.
What happened? Exams were going on?
Yes, ma'am. Exams were
Okay,
just finished.
So, how was your physics exam?
It was good. It went well.
It went well. Oh, then that's good. I have shared the notes, the link of this ray optics, the complete entire is there, though we have not discussed the other portion as well. Students like Zaid was asking me some other notes as well. Just write the name of the chapter for the notes which you are searching for. So I'll just then share the link for the same. Just let me know whatever is the chapter. Fine, Zaid?
Okay, ma'am.
But just find the name, just let me know. So we had started with total internal reflection and we didn't go further. Till here only we had discussed what's total internal reflection. So total internal reflection, we have studied that it's a phenomena when internally light ray gets reflected. Right, light ray gets reflected internally, means within that medium. So two conditions we had studied. First condition was that the light ray has to travel from the denser medium to the rarer medium. From the denser to the rarer. That is the first condition. Second condition is the angle or critical angle has to be exceeded. Critical angle gets exceeded, then only your internal reflection occur, total internal reflection. So what is the phenomenon of TIR? Light ray travels from denser to rarer medium with an angle greater than the critical angle. So light gets reflected within the denser surface only. And specifically, I have told you critical angle is also important. So critical angle is that angle of incidence for which angle of refraction in the other medium is 90 degree. And other medium will be what? Other medium will definitely be the refracting, rarer medium, because one is the denser medium. So this much we had discussed. One more thing, if you pay attention to sine IC part and just apply Snell's law over there. So how do we apply Snell's law? We take the refractive index of the medium multiplied by the sine of angle that is given, equal to whatever is the refractive index of the medium multiplied by sine of angle in that medium. Likewise, you can apply Snell's law. If you are not able to remember, sine I by sine R is equal to N2 by N1. If you are able to remember it like sine I by sine R is N2 by N1. N2 is the ray of light, the medium in which the ray of light enters. So whatever comes later will be written first in the numerator. So sine I by sine R is equal to N2 by N1, like this. But if you're having difficulties in writing which was N2, which is N1, what should come first, then directly write it like this. Refractive index of the medium multiplied by sine of whatever is the angle in that medium, be it angle of incidence, be it angle of refraction, be any angle that is given. So same thing here also, if we apply refractive index of rarer multiplied by sine R. Why sine R? Because your refraction is occurring in the rarer medium, is equal to ND into sine I. ND is refractive index of the denser medium, right? So this is it. And sine 90 will definitely, this is at the point of critical angle. Critical angles point. So sine 90 R will become 90 degree because angle of refraction was 90 degree. And this will be the statement. So simple formula of critical angle is sine IC is equal to 1 by NDR. So NDR means refractive index of denser divided by refractive index of rarer. But see class, this is very simple, though this is just application of Snell's law. But the questions that are present from total internal reflections and the questions that have come in your exams and already are present in CBSE previous years, there you have a lot of good questions present. Very much questions are there. They'll use this concept only. Sine IC is equal to 1 by India. The formula is this only. Application-based numericals will be so much. Application-based. Basic formula of it remains the same, definitely. Sin IC is equal to 1 by NDR. But the type of question that will be involving this concept will confuse you. You will notice I have two questions kept with you. One is a very easy one. Let's just do one. Then after that, we'll do those two questions which are very important. Then you will realize that how questions from TIR comes. So in the last class also I have mentioned, again I'm telling you, whenever you are studying TIR, that is total internal reflection, today we'll end it. We'll come finish off this in today's class only. Revise it today. Revise the basic concept. See, theory part are 2 lines. This is the topic from which theory questions can come, conceptual questions can come, and heavy numericals can come. Even from optical instruments, you get direct formula based question. That looks a little lengthy, but you have direct formula based questions. From total internal reflection, getting a very direct question, there's a very lesser chance. It means the question is from Snell's law, not from total internal reflection. See, one question is calculate critical angle for glass-air interface. So see, air, water, and glass, 3 refractive indices you should remember. One is air. Air, so you have to remember because air's refractive index is 1. So refractive index of air, you should remember. Rest of the refractive index of glass is 1.5. This also you can remember. And refractive index of water, 1.3. So 1.33, it's 1.33 and so. But here you have to remember, just remember it, 1.33 is there, but 1.3 will be sufficient for you. So 1.5 for glass, 1 for air, and 1.3 for water. These 3, please remember. Why I'm saying? Because it can happen that in your question paper, questions will be there which will be using the values of refractive index, but they'll not provide you the value for these 3. It can happen. Otherwise, in your maximum questions, it is given. Like in this question, this is a question that I've taken and no value was given. So in such questions, you have to stay alert for what are the values. So it says calculate the critical angle for glass-air interface. So sin IC is what? 1 by NDR. So ND is what? This is denser and this is rarer. So how do we calculate NDR? It is refractive index of denser by refractive index of rarer. And I have told you we calculate the optical density by the refractive index value, whatever value is the refractive index is holding. So ND, that is the refractive index of glass 1.5, air is 1. So keep the value of sin IC. This will become 1 by 1.5, right? So critical angle will become sine inverse 1 by 1.5. So this is the easiest type of question that is possible from critical angle and this TIR concept. Good numericals, we'll do at least two numericals. Let's do it. Note this down. The rest of the portions I think you had written. Did you all write this part? Yes or no? Those who were present last Sunday. Written?
No, ma'am.
No, ma'am, we wrote
Okay.
them the diagrams.
Okay. So let's write it from me.
Ma'am,
Yes, Anushka, say.
ma'am, yesterday there was no class, right? On Friday?
No, not yesterday. Last Friday we had the class.
Yes.
Ma'am,
Yes, Asta.
ma'am, if a question is given, how do you know that which medium is denser and which is rarer?
Looking at the refractive index. Maximum time you will have a medium like air, glass, water. So see that you can identify by looking at the refractive index.
So the
When the
one with the
refractive
higher
index, yes, that will
index will
be
be the denser one.
denser one. Yes.
Okay.
One question is there where a glass slab is there. See, glass slab is there. Angle of incidence is 70 degree. So this is air, this is glass, and refractive index that says n. So here what happens? There was theoretical part also written in the question. I have just escaped it and I have written the made the diagram. It says that a ray of light is incident, making an angle of 70 degree. This is a normal. And then refraction occurs. So at this interface, normal, simple refraction occurs. The way refraction phenomena, whatever you have studied, laws of refraction, everything occurs here. But when this ray of light strikes this surface, right, when this strikes this surface, let's say, we'll name the surface something. A is then, so B, C, D, we'll name it something. Then refraction angle becomes 90 degree. So it definitely means this is what angle? When angle of refraction is 90 degree.
Critical angle.
Critical angle, yes. Because this is a denser medium. This is given that this is glass. This medium is glass, this is provided. Fine. Air is 1. Refractive index here is 90 degree and it grazes over the last phase. You have to find out what is the value of the critical angle. So like this questions will come. Do you understand? Direct numericals you won't have. Otherwise you will be able to manage that. You will be having particular question where at just one single step your critical angles formula will get utilized. Otherwise, in total internal reflection, you have to use maximum things that are given in the question and whatever you have studied already. All these things get utilized whenever you study. Now see here, if let's firstly name the faces. Let's say this is B, C, D. All right. So if you look at this sine, and yes, sine 70 degrees value is also given in the question. This is a part of question. Because obviously sine 70 degrees value you don't need to remember. If you apply Snell's law at this vertical face BC, here, this is n, so n into, what did I say? Learn it by refractive index of the medium multiplied by sine of angle in that medium. So refractive index is n, sine of angle. What is the angle that is lying within this? Sine IC is equal to, here outer one is 1, that is here, into sine R. Right. Or even, why am I even writing R? You know, it's 90 degree sine IC will come directly 1 by n. Fine. Now see, I wanted to find critical angle. So my answer should have get solved by here. Right. Sine IC is there. Sine IC is 1 by n. So my answer should have been completed by now. IC will be sine inverse 1 by n. But we will not consider this. We will not consider this answer. The reason is that n is the refractive index of glass that I have taken by myself. N's value, specific value, whatever is the value is not given. So how can I write 1 by n? N is a variable that is particularly unique to me. N is not a variable that is given in the question. So what I'm trying to say is, whenever you're solving a numerical, if any variable is there, which is not given in the question, you had taken it for your convenience to solve the question. then definitely find out the value of that variable and put it into the question until you know its value. When you are aware of its value, then put it in the value of that variable in the question. Otherwise, do not take variables of your own and put it in the final answer. See, for the calculation, I'll be using n, but in my final answer, I'll not put n. Understood? Because many students I have seen in their test papers, not from your batch, from other batches, X, they have taken something by their own. And in the answer, I'm getting, let's say, 5x. So X was not given by the question. X was not provided by me. So how can I assume it to be correct? Understood? So just keep in mind, you have to find out the values of it. Now let's use, so now my target is to find n. Clear? Now coming to phase AB. Here, let's apply Snell's law. So again, Ayer's refractive index, that is 1 into sine 70 will be equal to n into this sine r. So this becomes 1 into sine 70 is equal to n into sine. Right now, I'm not aware of the value of this r, n or anything. Yes, sine 70 is given. Let's keep it.
And the sine 70 and all will be given in the question.
Yes, if such values are given of sine or cos or any value, which we should not learn. See, by you, from you, it is expected 0 degree, 30 degree, 60 degree, 45 degree, 90 degrees, and sine 53 and sine 37 maximum. Sine 37, sine 53, or cos 53, cos 37. That's it. Because one is 4 by 5, another one is 3 by 5. So that's why just, if any other value is given, no, sine 52 degree, like this, it will give you the value. If it does not provide you the value, then keep on putting it inversely. Do not take log table and start finding out the value between your exams. For you, this is for your final exams, for your board exams. Let's say sine 70 was not given in the question. Let's assume it. So how would I have solved the question? I would have kept it like sine r will be equal to sine 70 degree by n, like this. Then finally my answer, in the last part of my answer, very last part of my answer, let's say some value is there, I will write it again, sine inverse sine 70 by n only, like this only, if by chance in your exams, because for that a single score will not be deducted. All right, not even a single score will be deducted for it. But for sine 30 degree, don't make it sine 30 degree, sine inverse 30. That you have to write half only. All right, so such values if they are like sine 70, this was a part of question, though I had written it at the last, but it was a part of question. So this was given. Similarly, such atypical values will be provided to you in the question. And again, I'm saying, if it is not given, don't waste your time finding out the solution of mathematics will be dealt there. Whatever is there in your syllabus, how to find out the value, how to simplify. In physics, this is not required by all of you. So here, sine 70's value is given. So I'm substituting it. 0.9397 by n is the value of sine r. Okay, look at this triangle that has been formed. Yes, let's name this triangle something. This point M, let's make this point N, this point P. This triangle that has been formed, M, N, P. See class, this is if I extend both the normal, and since they are normal, definitely they are making an angle of 90 degree. So R plus IC plus 90 degree, all will have the sum 180 degree. So in triangle, what was the name of triangle? MNP, I think I had chosen. So R plus IC plus 90 degree is equal to 180 degree. IC plus R is equal to 90 degree. So R is what? R is 90 minus IC. So sine R I had written as 0.9397 by N. So I can replace R by 90 minus IC, which is equal to 0.9397, was the value of sine 70 by n. In this equation only, in this above equation, instead of R, I am writing 90 minus IC. So 90 minus theta is what? What is 90 minus theta? Sine 90 minus theta.
Cos theta.
Cos theta. Good, Astha. So it means if this is sine 90 minus IC, this becomes cos IC. So cos IC will be 0.9397, right, by n. Now, this identity I hope you all are aware of. Sine squared theta plus cos squared theta is equal to 1. Sine squared theta plus cos squared theta is equal to 1. Okay, Aryan's network is not working. So see, cos IC can be written as this. See, cos square IC plus sine square IC can be written as 1. Theta is IC, no? So theta is just a variable. You can replace it by IC, alpha, beta, gamma, anything. So I'm using IC. So sine square IC will be what? 1 minus cos square IC. So sine IC will become, and cos square IC will be what? See, cos IC is 0.9397 by n. So here this will become, sine square IC will become 1 minus cos square IC. Cos IC I had. So if I square it, that will become cos square IC. So 0.9397 by n square. And square of this, obviously square of this. And C class, I'm writing it 0.9397 all the time. Instead, if it's better, I'll write it as 0.94 only. Now sine IC is what? 1 minus, I'm writing it as 0.94. I'm just rounding it off. And with an under root. This is sine IC. Initially also I had found some value of sine IC, remember? 1 by n, from which we had started all these arguments. So sine IC was equal to 1 by n. It means I can replace now this sine IC by 1 by n. So that will become 0.94 whole square by n square. Now see class, this is a single equation with a single variable, that is n. It's a linear equation with one variable only. If I find the value of n from this equation, I can keep it in the main any of the formulas and I'll get the value of sine IC. I can place it here in this formula, or simply I can write it as sine IC is equal to 1 by n. N was the term that was troubling because directly we cannot assume n. Directly we cannot assume n, though we know it is glass given. We could have taken it as 1.5, but it's not necessary class. In questions, you have to find it out. In questions where you think the value like that question was there, glass air interface, like this, when the questions have no other variables, then you can put in the values. Otherwise, what I'm saying, that's what I'm saying. No, maximum values will be given to you in the question. Very rarely you have to assume anything, be it any trigonometric value or be it any variable. Now let's square both the terms. Now just solving. Simple mathematics is left. Square by n square. Let's take the LCM. That will get added. So 1 plus 0.94 square by n square is equal to 1. So this makes it n square is equal to 0.94 square plus 1. Yes. So 0.94 square plus 1 almost will give you 1.88, almost n square. 1.88. So instead of 1.5, we are getting a greater value, a little greater value, 1.8. So n is under root 1.88. So we have the approximate value of the refractive index now. Now you can complete your question. Now we can write down the answer. So sine IC, let's write it. It was 1 by n. So sine IC will be 1 by under root 1.88. Final answer, IC will be sine inverse 1 by under root 1.88. This is the final answer. So see, question was very lengthy and questions are lengthy. It's not that we have discussed it and it took time. No, these questions are lengthy. whenever you will also be doing, you will get stuck because finding out the correct equation becomes difficult. And how can you resolve it? By just practicing. So that's why I'm saying total internal reflection practice. Rest of the parts you'll get formula based question, like from apparent tips, the portion that we did last Saturday. We had seen the formula of it. So direct formula based questions are asked from it. Also, you have conceptual questions from it. So every topic has its certain unique part. But from total internal reflection, maximum parts are asked. Numericals to numericals. Theoretical part, so theoretical part will also come. So one more question we'll see. But before that, note it down. Whichever step you are not able to understand, let me know. Get it clarified, because these two were very important. One more we'll do, and these two are very important questions. Note it down. We'll discuss it if you have any doubts. One more question, class. See, this question says, okay, I'll read it. See, actually, there's a section of pipe. See, a cross section of pipe is given. Fine, a light pipe is given of glass fiber of refractive index. Refractive index is given for the inner one. This is 1.68, and for the outer one, this is 1.44. This is given to you. It says that when an incident ray, this incident ray falls on this interface. See, this actually becomes a kind of interface only, no, between the air and glass. So refraction will occur. Refraction is occurring from a rarer surface to a denser surface. Fine. This is a simple refraction that has occurred. Let's say this angle is R also. But again, same thing, when this R, this refracted ray strikes this inner hollow part of the wire or the pipe, no, pipe is given, no, of the pipe. So it gets totally internally reflected. It means this angle of incidence is definitely greater than critical angle. So we do not have to find out critical angle in this case, because critical angle is very obvious in this case. Both the refractive indices are provided. Critical angle could be calculated. So what is asked in this question? The values of angle of incidence. This is asked. I. What will be I? So definitely exact value we will not give, but at least greater than or equal to in terms of this we can give. I'll read the question once. Figure shows a cross section of light pipe made of glass fiber of refractive index 1.68, right? This I was saying, refractive index is 1.68. So the outer covering is made of the material of a refractive index 1.44. What is the range of angle of incident rays with axis of pipe for which TIR takes place inside the pipe? Same thing. C class, first step remains the same. First step, whenever you're also solving it, find out the apply Snell's law basically wherever critical angle is there. See, critical angle is not given here because this time the ray is not grazing over the surface. In the previous question, the ray was grazing over the surface. So when the ray grazes over the surface, that shows that this is critical angle given. But right now, this is totally internally getting reflected. So if it is getting totally internally reflected, this means this angle of incidence is greater than critical angle. See, what would have been the critical angle? Let's find out that first. See, sine IC is 1 by NDR. Refractive index of denser by refractive index of rarer. So same thing. No need to even think which is denser, greater, outer one or light, inside one. No. 1.68 is greater, 1.44 is smaller. End of the question. So sine IC will be what? See, it is 1 by NDR. So it means we have to reciprocate this term 1.44 by 1.68. So somehow your sine IC will be equal to 0.68 only. So sine IC will be 0.86. This is IC, sine IC. So this is sine IC given. But in our question, nowhere we require sine IC because critical angle's phase has been exceeded. That's why we have jumped into the phase of totally internally getting reflected, right? So for TIR to occur, the first condition, let's not say this angle is I. Let's say this is some I dash. Because this is not angle of incidence. This is not this angle of incidence. Neither this is this angle of incidence for which the ray entered, nor this is critical angle. So let's name it I dash so that variables are not become confusing. I dash is greater than critical angle, right? For total internal reflection to occur, this I dash should be greater than critical angle, right? It means sine I dash should be greater than sine sine I dash should be greater than sine IC. So it means sine I dash should be greater than or equal to 0.86. So sine I dash should be greater than or equal to, even we can put 0.86. Now I dash we have to substitute. So in that triangle that has been formed here, look in the figure, this triangle class, this. Again, I dash plus R will become 90 degree or not? Same thing. This is 90. This plus this will give you 180 degree. 190 gets subtracted. So again, same thing you will have. I dash plus R is equal to 90 degree. I dash you get as 90 minus R. Same thing. Sine 90 minus R will be greater than or equal to 0.86. Basically, the problem within this question is that sine R you are not aware of. This sine R. The way in the last question, the problem was refractive index of glass was not given. In this question, the problem is this R is not given, this angle of refraction. Because had we known this, we have all the refractive indices with us. So we could have easily calculated the value of angle of incidence using Snell's formula. So right now, my aim is to find out this angle of refraction. So this is sine 90 minus R. So again, cos R I can write, which is greater than or equal to 0.86. If I have cos R, finding out sine R is not difficult, 1 minus cos square R. Now do you see, we are coming closer to sine R, and if sine R is known, sine I can also be. So see, sine R can be written as under root 1 minus 0.86 whole square. So sine R will be greater than or equal to 0.26 upon. So sine R's approximate value I have. Now apply Snell's law at this point. Refractive index 1 sine I is equal to refractive index 1.68 multiplied by sine R. Now the sine R is known. Understood how to apply Snell's law? All those who have their basics weak for Snell's law, please ask me again. Sine I multiplied by the refractive index, that is air, is equal to 1.68 into sine R. So sine I is equal to 1.68 into 0.26. So sine I becomes greater than or equal to 0.436. So I is greater than or equal to sine inverse 0.44, I am right. This is the final answer. So did you see questions are lengthy? Questions are lengthy, but practice will make your work easier. First, tell me class. This question is clear to all of you? Both the questions clear?
Yes, ma'am, understood.
Others? Only Anushka has responded. What about others?
Could
Yes,
you
ma'am.
explain it again? Like with the figure, it's a bit confusing.
Which one? Which one, Astha?
This question.
This question? Yes, I'll explain. See, Astha. Here in this question, angle of incidence is unknown. So if I have sine R, so I can apply Snell's law. 1 into sine R is equal to sine R into 1.68. But sine R is only not given. It means first the task is to find out sine R. If anyhow I get the value of sine R, I'll be able to find out angle of incidence. Do you agree till here?
Yes, ma'am.
All right. Okay. Now see class. Firstly, what did we do? We calculated the value of sine IC. That is critical angle. If I have the value of critical angle and here total internal reflection is occurring, so this is showing that this angle is definitely greater than critical angle, then only this total internal reflection is occurring. And I have found the value of sine IC. So if you have the values of sine IC, it means sine I dash will be greater than sine IC. I dash is greater than IC. So sine I dash will be greater than sine IC. And sine IC we already have. Yes, Asta, say.
Ma'am, it's given in the question that total internal reflection has occurred.
Yes, it is given in the question. It is given in the question as well as it is given in the figure also. See, for which PIR occurs here. Total internal reflection is occurring. Also, in the figure also it was given. The complete figure is given. This I have not completed the figure. And also completion of figures will be given to you in ray diagrams, not in such questions. So it means TIR is occurring. That's why. This is not we have chosen, like otherwise, yes, that will be a good question. Then how can you say that TIR is occurring? So TIR is occurring. That is given. So once we know, so assign I dash we have calculated. And I dash can be replaced by 90 minus R from that triangle. Once you have 90 minus R, you get cos R. As soon as you get the value of cos R, finding out sin R is now not difficult. Cos square theta plus sin square theta gives you 1. Now I have sin R, and then at the last I have applied the Snell's law that gave this value of sin. Now clear?
Yes, ma'am.
Okay. So note it down then, class. Then we are just left with the applications. Applications, we'll discuss it quickly. Then at least this topic will be over. So question first, write it down. And class, mark this question important. Mark this question important because this is application-based question as well. You will see how this is. Once let us just discuss the applications of TIR, then you will see. Class, coming to the applications of total internal reflection, that is the last topic from this heading, that is TIR. So again, I'm saying revise TIR. Applications will be there, application-based questions will be there, tough numericals can be there, direct definition and conditions of TIR, that can also be asked to you. Now, see, there are few applications where total internal reflection is used. Just listen, I have written the things, I have pre-written things, so just understand it. First thing that comes is mirage formation. So most of you must be aware of it. Some of you might be not aware of it. This is basically an optical illusion that occurs. See, the layers of atmosphere are present. Different layers of atmosphere are present. And if I'm saying layers are present, then definitely means there's a change in refractive index. Because if the refractive index was not to change, we would have got a clear one atmosphere. But since it is changing, that is only showing you that yes, atmospheric layers, they are present. The atmosphere is present in the environment, basically, you can say. So the refractive index that is closer to the Earth is less. It is rarer. Then slowly and gradually, the refractive index keep on increasing as we go up the higher altitudes. Where the temperature is low, the refractive index is greater. Then what happens as, see, object I have told you we had discussed initially, remember when we started with ray optics, that time only we discussed that an object is just a source of light. It can be luminous, it can be non-luminous. When I say it is luminous, that means it is emitting light of its own. When I'm saying it's non-luminous, it means light rays are falling on it. So let's say light rays are falling. I have taken the example of this tree. So light rays are falling, then it gets refracted. Gets refracted by? Gets refracted in the sense the angle of, because of atmosphere, from denser to rarer, it gets refracted. Again, it will get refracted. It will keep on getting refracted. It will keep on getting refracted because of different layers of atmosphere. If by chance at any point, this happens rarely, again, I'm telling you, this is not a very common phenomenon, especially in cities, definitely not there. In desert areas, it is possible where dry, hot, sunny environment is there. So it gets refracted, but if at any point of time when the angle of incidence becomes greater than the critical angle, total internal reflection occurs. And when TIR occurs, then the image is formed then and there only. No need for a screen, no need for a mirror to be present. It means it will appear, I'll give you an example. Sky is there, bluish color sky. TIR occurs, optical illusion occurs from denser to rarer, all the rays pass, and the image, and somehow at one point, it gets totally internally reflected because angle of incidence becomes greater than angle of critical angle. So image is formed directly on the road. So at a far distance, so when you are situated at a little distance, let's say some meters, 5 to 10 meters, you can say very small distance, you will observe that water is present on the ground. On a very hot sunny day, it will appear to you that yes, water is present on the ground. But when you will go near it, you will see the road is completely dry, but you were able to see water. It's not magic, it's just simply optical illusion. Optical illusion means something that is not present, but we are able to see it. So that is basically the reflection of sky was formed that appeared bluish on the road, that which we perceived as water. So same thing, let's say here a tree is formed. So an image of tree you will be able to see, not a very clear good image, the way images are formed in mirror, but slight colorations and the slight abrupted margins you will be able to observe. So this is one phenomena, and this phenomena is known as mirage formation. The image that is formed of an object where no refracting surface is present, where no reflecting surface is present, but both refraction and reflection keep on occurring. And same thing, for TIR, conditions have to be satisfied. It means denser to rarer and angle more than critical angle. Then one is brilliance of diamonds. See, if you take diamond and you slightly move it, even if you do not move it, Diamonds sparkle, right? Diamonds shine, they keep on sparkling. Basically, it's just the structure in which they are constructed that once the light ray gets into it, it keeps on getting totally internally reflected at all the phases of it. At all the phases of it, it gets totally internally reflected. Because it is constructed in such a manner that angle of incidence has to be greater than critical angle. And that is calculated using experiments. It came out to be 27 degrees. 27 degrees will not be asked in your exam, but if you get a question on the applications of TIR and you add critical angle of diamonds by yourself as 27 degree, so that will give more power to your answer. That's why I have just written. Otherwise, a direct question will not be asked to you. Just a second. Okay, so yes, so and also one thing is that it has small critical angle which is 27 degree. Light basically gets trapped, so light ray does not come out. So when the light ray is falling within that small diamond, no, that is the brilliance of diamond which we observe. So second application. Third application is using a prism and the application of TIR. You can shift the object's view and form the image according to your wish. See, for glass, for prism, you have the critical angle as 42 degrees. Now see, if I want to reflect light ray by 90 degree, what will I do? I'll keep the right angled prism in such a manner. Prism, we have a separate topic as well also. So I have kept the object in this phase. Now see, light rays are coming. It is getting reflected, totally internally reflected. Again, light rays are coming, getting totally internally reflected. Where the light rays will come out, draw an image, you will see it is exactly reflected by 90 degrees. Initially it was AB, now it is A dash B dash. What if you want to reflect it by 180 degree? So you'll keep this phase, that was the hypotenuse of the right angle triangle, as the incident phase. So incident rays will come, it will get reflected, it will again get totally internally reflected. Same thing, reflected, reflected, reflected. It keeps on getting totally internally reflected. So AB was the object, A dash B dash is formed as the image. So exactly it is getting reversed by 180 degrees. Last is the question that we did. That was, I was saying that we'll discuss it. The optical fibers have their applications in the applications of TIR. Question also you had done just now, that was an optical fibers condition where light ray, once it enters, it keeps on getting totally internally reflected. So optical fibers, you almost have seen those mouses that we have within the desktops or laptops, which has red light below it. So those are optical mouses. So the wire that is used for the construction of optical mouse, that is optical fiber only. And that uses and applies the phenomena of total internal reflection. So details you can refer to the book also. You can write it on in your words as well. But at least note it down such points, so at least you'll have an idea what you have to write in the exam.
Ma'am, can you show the third one, totally reflecting present? Yes, ma'am, scroll.
Optical fiber, critical angle will be small, right?
Yes, for optical fibers also, critical angle will be small only, mainly. And the type of question that we did. So somehow the mechanism will work in that manner only.
Okay.
Today's class is till 7.
It's half an hour more is left in the class.
Okay, ma'am.
Okay. Your duration is now 2 hours only. Because see class, next weekend we'll be able to finish ray optics. Then after the next weekend means the month of December will only begin. That time we'll be able to start with wave optics. So that's why 2 hour class is needed this time. Okay, now next topic is spherically refracting surfaces. See, we did what? We took a sphere, we cut it. The part that we received, we silvered it. So the silvered part, wherever silver linings were obtained, this silvering, this part, wherever you could, let's say, let me hide it. Let's say here you have silvered it. So this silvered part, this made it the mirror. Let's say if the outer part is silvered, then inner part acts as gives the surface area for reflection to occur. So we call this device as mirror. If I take this surface, instead of painting it, I keep it plain. Instead of painting it, I keep it plain like this. That will also allow refraction to occur. That won't allow reflection to occur, but refraction will still be allowed because this medium is air. And let's say this is the glass part, spherical refracting glass part is there. Rays will come. So this is two media are involved right now. One is air part, another part, one is glass part. So it means now also refraction will occur. So one is your convex surface, other one becomes your concave surface. So you have denser, wherever you will be having the glass part. Let's say this is the glass part and this is the outer bulged part, right? This is the glass part and this is the bulged part. So it means this is a convex surface. This is a convex surface. From here it cannot be constructed, but let's say in this shape, if you have a glass, the glass part is here as a concavity at the end. So that is the concave surface. This is how you will identify concave and convex surface. We have a relation between object distance, image distance, refractive index, and both the refractive indices and the radius of curvature that we have to start. So this is just an overview of what you have to learn. See, refraction can occur from rarer to denser. That is, object is in rarer, image is formed in denser for both the convex and concave lens. And same thing, refraction can occur from denser to rarer. Again, object is in denser and image is in rarer, convex and concave surfaces both. So no need to write down this part. This I just wrote it for your understanding. Let's start with it from rarer to denser. Do one thing, just note this part, the first line. These part, just write it down. then their relation's derivation is there. It's that way. Just note it down quickly, then let's do it. So refraction is occurring from rarer to denser medium. So this is a surface. I have chosen a, let's say this is the surface, this is N1, this is N2. Fine. Now see, object is here. Fine, object is here. So light ray is falling from object, it is falling onto the surface. Now see, this sphere will be having its center of curvature. So center of curvature is present here. Then I told you that whenever you have to draw the normal, so dropping the normal is easier if you connect it to center of curvature. This is how you drop a normal. So it means this becomes angle of incidence because this is the incident ray. This is incident ray. Now see, here what will happen? Normal I have drawn, incident ray is present. Now the phenomena of refraction will occur because both media are different. I'm not considering one as something. Right now I'm just taking it as general, N1 and N2. Let's say refraction occurs and at this particular point, I am getting the image. Now I am taking random angles, alpha, beta, gamma. They have no physical meaning. What is the definition of alpha, beta? No, nothing. This is just for your derivation purpose. And one more thing, I am dropping a perpendicular because see, I want triangles to derive the formula, to derive the numerical. But this is a curved part. This pole is a curved part. So that's why I've dropped the normal. So at the end, what will I do? Let's say this is M, this is N. At then I'll exchange N with M. All right, I'll exchange this with P. N and P I'll exchange because both are so close to each other. Right now, for this calculation purpose, I'm using this perpendicular Mn. Now see, if you apply Snell's law at this point M, so sine N1 into sine I will be equal to N2 into sine R. Yes, sine R will be what? This ray of light is getting refracted and this was the normal. So this is R. All right, this is angle of it will be confusing with gamma. No, let me draw it a little different. This is R, angle of refraction. This is the normal orange one. Fine, so this is usual Snell's law. Now, if you apply small angles approximation, sine I, C class, whenever you have small angle approximation, angle is less than angle is less than 15 degrees, like 7 degree, 3 degree, 2 degrees, 0.2 degrees, such small angles are there. So whatever value you will get now after putting it into sine theta, that will be the same value as the angle. It means sine, let's say 2 degrees. So value of sine 2 degrees will almost be equal to 2 only. So sine theta is almost equal to theta. This is valid for tan also. Tan theta is also almost equal to theta if it is small angle approximation. So here the aperture is small, we'll apply it. So instead of sine I, now I can write only I is equal to sine I, so N2 into R only. Now look at this triangle, OMC. Have a look, OMC, this triangle. All of you should remember exterior triangle property. Exterior angle property of a triangle says that the exterior angle is the sum of the two opposite interior angles. This you all have done in your 10th standard. This is just a reminder. So exterior angle, if you look, triangle OMC, can anyone tell me what is the exterior angle in this triangle OMC?
I.
Good. And opposite angles are alpha and gamma. So it means in triangle OMC, I is equal to alpha plus gamma. Fine. This is alpha plus gamma. Also, look at this triangle here. This triangle. Triangle MCI. This triangle, if you have a look here, triangle MCI. C class, here, what is the exterior angle? Triangle MCI? Gamma. Yes, right. And opposite angles are R and beta. So it means in triangle MCI, gamma is equal to R plus beta. So R is what? R is equal to gamma minus beta. Now I have value of I have value of R. I'll keep it here. So N1 into I is alpha plus gamma is equal to N2 into R. R is gamma minus beta. Now see, look at the triangles. What did I say? Sine theta is also almost equal to theta as well as tan theta is almost equal to theta. Now I'll be using tan. Alpha is where, look at this triangle OMN. Tan alpha will be equal to perpendicular, that is MN, by base, that is ON. Please class, stop me wherever you're not understanding. All right, this derivation is not very difficult though. So tan alpha is perpendicular by base, MN by ON. Similarly, if you see triangle, look at MNI, this triangle. So tan beta will be equal to what? MN by NI. Agreed? Tan beta will be MN by NI. Same thing, if you look at this triangle MNC, angle gamma, that is tan gamma will be MN by NC. So these are certain values using just the perpendicular. So see, when you use small angle approximation, let's say in triangle OMN, we used tan alpha. So instead of writing tan alpha, I'll almost write alpha is equal to MN by ON. I'll use alpha only. And then in triangle MNI we had, so tan beta was almost equal, it will be almost equal to beta. This we will use, which is equal to MN by NI. Last was what? Gamma, MNC. MNC was the triangle. So in triangle MNC, tan gamma will almost be equal to gamma, which will be mn by nc. Now I have values of alpha, beta, gamma. In this equation, alpha, gamma, beta, all are used. Let's put the values of alpha, beta, gamma in terms of these alphabets. So what you will get? N1 was there. So it was alpha plus gamma. That is mn by on plus mn by nc. Alpha plus gamma is equal to n2 into gamma minus beta. Mn by n. Right. See class, mn gets cancelled from everywhere. And 1 is equal to 1 by on plus 1 by nc is equal to n2, 1 by nc minus 1 by ni. What did I discuss with you? The pole and n. These are very small points which are close to each other, located very close to each other. So instead of writing it all the time as on, I'll write it as op. Understood? Like, see why OP? Because ON is nothing. OP is the object distance, right? And C is nothing. PC is the radius of curvature. NI is nothing. PI is the image distance. And these are positive. And object distance, this will be negative. That's why we are using small angle approximation. And if we didn't mark this point N, we wouldn't have got all the triangles that we were using. So where I was, yes. So I'm replacing this N1, or instead, no, let me write it all together. C class, in this figure, which figure we had, ON is equal to OP, which is minus U object distance. NI is equal to PI, which is equal to image distance. NC. NC is equal to PC, which is equal to radius of curvature. Now N1 will be equal to 1 by minus U plus 1 by R is equal to N2 into 1 by R minus 1 by V. So this is the formula. We just have to simplify it a little bit. Let's multiply N1 here. That makes it N1 by minus U plus N1 by R is equal to, let's multiply N2 also. That makes it N2 by R minus N2 by V. So let's put the radius of curvature term together. N1 by minus U plus N2 by V is equal to N2 by R minus N1 by R. Here, if you wish, you can take 1 by R common. Otherwise, you have got your answer. N1 by minus U plus N2 by V is equal to 1 by R, N2 minus N1. This is the formula for spherically refracting surfaces from rarer to denser. You have to use proper sign convention. I'm telling it every time because students commit error whenever they are asked to write down the formula and use the form. Fine. This is it. See, one more thing, class. If by chance it is opposite, denser to rarer is asked to you. Let's say denser to rarer is asked to you. See, the difference will be in the figure. This time, this will be the surface, right? This will be the denser surface. This will be the rarer surface. This will be N2, this will be N1. Object will be here. But center of curvature will also be here. No, so normal will be here. This will be the normal. Refraction will occur here. This is image distance. So see, angle of incidence is what? Angle made between the incident ray and the normal. So this is the incident ray and this is the normal. And angle of refraction is angle made between the refracted ray and the normal. This is angle of refraction. Here, this is alpha. This we chose as gamma and this was beta. Difference will come that now R will be equal to beta plus gamma. R is equal to beta plus gamma. And oppositely, I will be equal to, see, gamma is equal to I plus alpha. So gamma minus alpha, right? Yes, gamma minus alpha. This will be the difference. Same procedures you will apply, same steps you will apply. All the steps will remain the same. Just will be just the difference. And answer will be wherever you were having 2, now you will be having 1. This will be N2 by minus U plus N1 by V is equal to N1 minus N2 by R. And here also you have to use proper sign convention. Noted till here, not a very difficult derivation. You will be able to manage it. Just remember the diagram for the derivation. Once you remember the diagram, you will be able to handle it. Yes, class, one more thing. Last weekend, we didn't have the test of EM waves, no? So tomorrow I'll take that test. That was already announced for the last weekend. Last weekend, we didn't have the test. So tomorrow I'll take the test. Half an hour test is there for EM waves. EM waves test we didn't have, no, in the class.
No. Ma'am, I think we did. We had a test for EM waves, right?
No, we didn't have.
For EM waves, we didn't have. No, we didn't have for EM waves. We were supposed to have it, but because of the syllabus, no, I didn't take it last week. Last
ma'am.
weekend only, that was announced. So you all must be prepared for it only. Just give the test tomorrow for EM waves. Fine.
Yes, ma'am.
Simple questions are there. You all will be able to manage it. So tomorrow I'll take. And next weekend, we'll try to complete with this lesson at least. Note it down, note all these points. Any doubts you have in between, ask me.
Ma'am,
Ma'am,
the
tomorrow I
test will
have
be for.
Yes, Anushka, say.
Ma'am, the test will be for how many marks?
Test is, I think, for 20 marks or 15 marks like this. Usually, I take the test before revision classes are beginning. I'm taking the test for 10, 15 or maximum 20 marks. So this should be, I don't remember it right now. So this will be the limit only. See, I'll tell you, questions are from electromagnetic spectrum part. Please prepare that. That is very important. Electromagnetic spectrum, comparison of wavelength. And another part is from that. E is equal to E naught sine theta, sine omega t plus kx, that we did. And B is equal to B naught sine. Those two equations which we did for the properties of EM waves. From these two topics, I have questions. So mainly, see, paper is not lengthy, not at all. You'll be able to complete it in half an hour. Mainly that electromagnetic spectrums questions are there. So prepare that. Zed, you were saying something?
ma'am, tomorrow I have a unit test of ray optics. So any important topics?
Yes, ray optics. Okay. So again, Zed, today's class you've attended, it's good. So total internal reflection, as I was saying, a difficult question can be asked from it. Ray optics, no, the simple basic formulas of lens formula, yes, one more thing. I think we didn't do it till now, no? No, we have not
Lens
done.
maker formula, right?
Lens maker formula, yes. Lens maker formula. Lens maker formula is very important. For optical instruments, you can even learn the final formula, no? That will be sufficient for the answer because direct questions are asked from optical instruments. Prism questions are there, angle of minimum deviation. That questions are asked, angle of minimum deviation, those are asked from the topics that we have not done. Lens formula and mirror formula, simple questions are there. Combination of lens question can be asked there. In your NCRT, I think last question that is given, question 30 or something, combination of lens is there, one convex, one concave, one convex, that, right? So that also, that type of questions that are also important from lens part. From mirrors, same thing. Mirrors, basic things there are. Spherically refracting surfaces can be asked, like a spherical bubble is given. So one side it is acting as concave, other as convex, one rarer to denser, other denser to rarer, what we have done just now. So those parts are important. Otherwise, from reflection, see, yes, reflection is added recently in your syllabus. So reflections questions will be basic, but chances are there in your board examination, chances are there that it can come. Regarding school examination also, if the questions come, it will be simple from reflection. But from dispersion, prepare your application-based question, rainbow formation and all those dispersion questions from prism. Fine. These topics are sufficient. And lens maker formula and total internal reflection, these are some very pet questions.
Ma'am, for this refraction from rarer to denser medium, this derivation is asked in like exams.
This derivation was asked in the exam once or twice. It is asked. Not usually it comes, but it can be asked to you. There are chances it can be asked because the derivation part is not difficult. If you notice, just the angles you have to write and just put in the values and just cancelling it. So it can be asked to you, and it has been asked in the board exam. If you see previous year questions, it has been asked. So yes, prepare it once also, once you see. Just remember one part, no, other derivation becomes simpler. A change in diagram and the final formula.
Okay, ma'am. Ma'am,
Yes, Astha.
ma'am, these formulas are applicable for both the lenses, convex and concave.
Yes, both the lenses, convex and concave. Just remember the medium, rarer to denser or denser to rare. That is important. Rest of it, apply sign conventions. Most of your questions will be solved.
Yes, ma'am.
As you will complete class, just text me done and you all can leave now. Already your time is up. 3 minutes have gone. You all can text me done. All those who have completed, you all can keep on leaving the meeting. So tomorrow we'll continue from here. 1 or 2 numericals at least we'll do from this portion, and then we'll go to the part lens maker formula. Okay. If you're done, yes, you all can do. Thank you so much, class.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am.